Alzheimer's is a disease which affects 44 million people around the world. It's currently an incurable disease because scientists do not have a solid understanding of how the causes of Alzheimer's directly relate to the symptoms. However, scientists at Cornell have found that a decrease in blood flow to the brain caused by white blood cells blocking capillaries is the potential cause. But these researchers require large amounts of organized data to understand how blood flowing directly impacts Alzheimer's. This organized data is in the form of videos of blood flowing through the brain, which are either stalled or flowing. But sorting through those videos takes weeks. I've created a deep learning algorithm which can classify these videos of blood flowing in the brain in hours. It uses a convolutional neural net, or CNN, which loops through each frame to classify it into either stalled or flowing. It then takes the average prediction from all those frames and outputs that prediction as the whole video's prediction. A CNN consists of three distinct layers: a convolutional layer, a pooling layer, and a fully connected layer. The convolutional layer consists of different sized kernels which pass over the image, applying weights and biases to the pixel values and outputting a new value into a smaller matrix. The pooling layer is a lot similar to the convolutional layer in that it has different sized kernels, but instead it takes the highest pixel value, which is what we're doing in our case. Finally, there's a fully connected layer, which is similar to a neural net in that it has nodes which apply weights and biases, ultimately giving a classification. This classification is either 1 for stalled or 0 for flowing, meaning we're using a sigmoid function to give a value in between 0 and 1, where if it's greater than 0.5, it's stalled. This model had 96% training accuracy, which is kind of suspicious, and when applied to a new videos for testing, the MCC score was 0.05. Now, this is not the best accuracy, and there's still room for it to improve, as there's most likely some overfitting going on. And the next step that I suggest doing is using an LSTM, which allows the model to understand how time is involved with each of the frames. So stay tuned for my revisions to the algorithm.